Okay, we've got some energy situations here now. What we have charge Q1. It's got a charge and a mass. It's located 5 meters from Q2. Okay, so that's just our original. This rest of this stuff is just part of the question as it progresses. So this one is this far from this one. First thing we want to do is calculate how much work must be done to move Q1, this one, 2 meters closer to Q2. So what we're going to do is we're actually going to take this thing and we're going to force it to here. And by doing that, we're increasing the amount of energy that's going to be stored between these two things because we're bringing them closer together. So I guess we need to get this energy formula. It's K Q1 Q2 over R. It's not R squared anymore. And what we want to do is we want to figure out what our initial value for energy is. So how much energy is there stored between this one being here and here? So that's going to be energy at my initial position. So that's going to be 9 times 10 to the 9 and 2 times 10 to the minus 6 and 5 times 10 to the minus 6 over top of my distance, 5 meters. So my initial energy in this system is 0.018 joules. Okay, initially that's my potential energy. If I released it, that's how much energy I could use to calculate velocities or whatever. What I want to do is figure out my final energy as well. So let's assume that I've done my move, I brought it to here, and now what I'm going to do is figure out how much energy is at that position. So that's going to be 2 times 10 to the minus 6, 5 times 10 to the minus 6. Nothing changes except the fact that you're now 3 meters away from here. So you divide that by 3. So your final energy ends up being 0.03 joules. So when you actually do the math on this, we want to figure out how much energy must be done to move it from here to here. So we're just looking for our change in energy. This is part A. Change in energy is going to be equal to final minus initial, always, which means that you're going to go 0.03, subtract it from 0.018, and you will be left with how much? Equals 0.012 joules. That is energy needed to move it closer. So energy needed to move it 2 meters closer. Or you can think of it as a gain in potential energy based on the position of the two positives. They're really trying to repel apart, and we've gained that much more energy. What I would like to do for part B is the charge is now released. How fast will it be going when it passes its original position? So I take it from here, I release it, and it's going to shoot off this way. And I want to figure out how fast it's going right here. So if you look at the amount of energy it took us to get from here to here, we had to add or gained that much energy. When we release it, it's going to actually lose this much energy, and it's going to convert it into kinetic energy. So your potential energy is basically going to get converted into kinetic. Well, your potential, you've got this much energy to convert into 1/2 mv squared. So 0.012 is going to be equal to 1/2. Your mass was 2.5 times 10 to the minus 6, and we want to calculate v squared off of that. So that's going to be 2 times 0.012 divided by 2.5 times 10 to the minus 6, and that's all square rooted. And when you're done, you're going to end up with a velocity of 97.9 meters per second left, because when you release this thing, it goes left. There you go.